Hey everybody, and welcome to episode 49 of the iPhreaks show. This week on our panel we have Pete Hodgson.
Hello from San Francisco.
James Zuber.
Hello from Minneapolis.
I'm Charles Max Wood from DevChat.tv, and we have a special guest this week, Terry Lewis.
Hi, this is Terry, and I'm in Houston.
So you're our Houston guy because Ben's not here, huh?
Yeah, I guess I'll pretend to be Ben.
There always has to be one.
Yeah, I thought there can only be one.
You actually work with Ben, right?
I do, actually. Yeah, we work at the same company. I don't work directly with him on a project right now, but yeah, we're in the same office.
Do you want to introduce yourself? We can get all the gory details.
Sure. I'm actually not an incredibly long-time developer. I worked retail for a long time, and I was like, hey, I don't want to work retail anymore. I'd like to make more money and do something more interesting. And so I decided to go to school for computer science. And I did that about a little over 2 years ago. And I started doing iPhone stuff right after I started school because I didn't want to write Java command line applications. And so I've been doing iPhone stuff ever since. I did some contracting for a while, and I recently moved out to Houston for a job with Ben and the company we both work for now.
Cool. Well, I'd ask you how you like it, but Ben is a regular on the show, so you sound pretty happy, though, so we'll just leave it at that. We brought you on today to talk about ReactiveCocoa.
Yep. So I'm guessing we're going to go at this from, I guess, a little lower level perspective, as in you've not really heard of it before, or you've heard of it but haven't really messed with it. So ReactiveCocoa is an implementation of functional reactive programming. And functional reactive programming, you break it down, you have functional programming, which is languages such as Haskell or Scala, and the focus is on functions, with functions being first-class citizens in the language. You can create them anywhere, you can pass them to other functions, you can return them, so forth and so on. And we have this with blocks in Objective-C, though they're not quite to the level of first-class functions in true functional languages. And then the reactive part is simply what it says. It's reacting to change in your app. And you can just think of Excel or a spreadsheet for this. You put in your formula, and then you put in numbers, and it updates itself. You don't have to say reload every time you change a number. It just updates for you. It's reacting to the changes. And you would probably not use Excel or a spreadsheet if you had to manually update it. So the reactive part, not only does it give us a good paradigm to work with at the code level as developers, you can actually create much better user experiences for the users of our apps. Which again, Excel, you wouldn't use it if you had to manually reload changes. And so you can translate this into better user experiences. So that's sort of the high-level overview of the functional and React part.
So I'm kind of curious, what is the traditional approach to the problem that ReactiveCocoa solves as opposed to, doing this functional reactive programming? So what do most people do if you update, say, a field in your UI and you need it to update some other text or something further on in the app?
Well, for iOS, you might have delegates, you might have a block callback, you might have a notification. There's any number of methods to do these things, and the things that you do in ReactiveCocoa aren't impossible to do with normal imperative code, but again, it'll give you a cleaner way to do it. So yeah, I mean, like I said, you use notifications. I update this UI element now, or this model element, now update this UI, let me post a notification, or a delegate or whatnot. So there are various and sundry ways of doing that imperatively that we've all used. And they're all effective, but ReactiveCocoa does things in a different way.
I guess maybe another, like an analogy that maybe would get the idea across of like the imperative versus declarative thing is like using SQL instead of like looping through stuff directly. So you could query a database by saying, I want to get all the list of elements and then I want to loop through them. And if the thing is less than this, then I want to grab these 5 bits of it and do it all kind of like imperatively, like step by step. But with SQL, you can kind of raise the level of abstraction and be more declarative and just say, give me, I want this collection filtered by this criteria. You figure it out, computer. I just want the results. So I kind of feel like reactive functional stuff is kind of the same, but for UI. So rather than manually, rather than sticking callbacks on things and saying, okay, this has happened, so I'm going to get this thing over here and put it over there. You just kind of set up the flow of information and then let the computer or let the compiler figure out all of the details.
Yeah, and that's a good analogy. It's very declarative. Another one I like to use is auto layout. If you haven't used auto layout, you should be. But with auto layout, you say, here are constraints for this view, and view lay yourself out. You don't worry about actually setting the frame of the view. You just set some constraints, and the view handles all its layout. And it doesn't matter in the order you specify these constraints, but yeah, so it's a higher level, it's a declarative thing. And ReactiveCocoa and functional programming in general provide this style of programming where you say more of what you want done rather than how you want to do it.
So how does this work in like a typical view controller? Seems like a very different way from how we're used to kind of developing our UI.
Well, you still have, the canonical example is that I use when I've got some examples and others have used are text fields. So you have a login form and you have a name, an email, and a password field. Well, you might, depending on how you do it imperatively, you might set those fields and you have a login button that'll do some action login when the fields are done. And you might validate the fields. Perhaps when you hit the login button, you might grab all the values from the fields, maybe do some validation, set them on your model object, and then send it off. The way you would do this in ReactiveCocoa, you could set up connections from all your fields, which you would get signals. They call them the classes rack signal. So you get signals from all these fields, and you would transform them and do validation on them before you actually set them on your model object or let the request be fired off. So it's definitely different. And you can do all this logic with ReactiveCocoa. You could just declare it in view did load. So for a small view controller, you could have the entirety of your logic in view did load, and it would all just work.
Okay, I think we skipped past a little bit on exactly what ReactiveCocoa is. This is a library that you can download from GitHub or something?
Yeah, it's completely open source. It does have a Cocoa pod, thankfully, because installing it the manual way is a little bit more of a pain. So yeah, it's a completely open source library, and it lets you do functional reactive programming in OS X or iOS apps.
Okay, so a typical use case would be in our view did load, we would wire up some validation type logic that we would assign it somehow with the ReactiveCocoa framework, and as the text changes in the text field, we could kind of enable or disable buttons. Does that sound like a reasonable use case?
Yeah, that's basically what you would do. You would take the text and you could transform the text into, say, a Boolean that would indicate whether maybe the create account button was enabled or not. And you could take the text from all the text fields, so you don't want to be able to create an account until all the text fields are enabled, and you can combine all those values into one Boolean that says the field is enabled or the field is disabled. And so, yeah, you do a lot of transforming of your data. You'll see a lot of map and filter and reduce going on in ReactiveCocoa.
Okay, what's the map, filter, and reduce for those who may not be kind of familiar with that?
Well, we are sadly missing these methods in Foundation. They're available in Ruby and many other languages, but map is what we would call a higher order function, and it's a better way to transform a list. You usually see it on lists, and instead of writing maybe a for loop, taking some data from an array, doing something with it, transforming it, adding it to a new mutable array, and then using that new mutable array, map, you pass a function to the map method, and you get the element from the array, and you transform it and return that, and map returns a new array of the transformed elements. So it's a higher level way of basically iterating through an array and changing the values to something else and getting a new array back.
Okay, so I've got array of strings, and I want to add iPhreaks rule to all the strings. So I would use a map or something like that. Does that sound right?
Yeah, you could call map, call in a stringless format, add iPhreaks rule into the string, and just return that, and you get a new array with those transformed strings.
Okay, very cool. Yeah, that's something that's available to us in a lot of different frameworks. I did a lot of C# and Link does a lot of that kind of map reduce type stuff. Ruby does it. But yeah, that's one thing I definitely missed coming into doing Objective-C. So I like having those type of operations. They can really help clean up your code. But at this point, I've gotten so used to doing just for loops, for 0, I++. It's hard to step back, but it's very cool.
That's like a really good, the map I think is like a really good, it's an example that everyone can understand of what we mean when we talk about functional programming, kind of changing things from imperative to declarative. You just say like, you capture the essence of what you want to do. I want to add this string to this other string, and you let the library or the framework or whatever take care of the boring stuff of maintaining counters and looping through things. So it means that the code's easier to write, but it also means it expresses its intent better, so it's easier to understand and easier to maintain.
Now, are those functional constructs built into ReactiveCocoa, or do you get them from somewhere else? Are they part of Objective-C?
They are built into ReactiveCocoa, so you have map and filter and reduce. These are all methods in ReactiveCocoa, and you deal with these on the signals that you get from ReactiveCocoa. So they're not operating on collections like they normally do in other languages, but they're operating on what ReactiveCocoa calls signals. So you don't just get it for random objects in Objective-C when you pull in ReactiveCocoa.
Okay.
So the difference there, as I understand it, is that, in the traditional, or not traditional, but in the kind of the way that the map thing that I think a lot of people would be familiar with, of, looping through an array, you take the whole array, you loop through it, and you get another array. Whereas with these signals, you're not necessarily going to do the work there and then. You're just kind of setting up you're kind of slotting together a series of kind of connected pipes. And you're just saying, when something happens, flow it through all of these operations and, map this to that and then filter it by that and blah, blah, blah. But that operation isn't necessarily going to take place right now. It's going to take place at some point in the future when someone interacts with the system.
Yeah, and that's a pretty good analogy. Like you can get a signal from a text field, and that signal will send a new value every time the text field changes. So you can set up all these transformations on this signal from the text field, but if the text never changes, if no one ever enters anything into the text field, then none of that work will ever be done. So you're setting all these pipes up, like you said, and all these chains, but they're just waiting on data. And so, yeah, you can set all these up, and they may or may not actually do anything, depending on if they actually receive data.
So one thing you said that's kind of interesting. So we're connecting a signal to like a text field. How does that work? What's going on under the hood there?
The main class you interact with in ReactiveCocoa is called ReactSignal. And you can generally think of signals as a pipe. It's just a wrapper around your data, any data. And it carries this data along, and it lets you transform it and filter it and do all these operations to it, and it just ferries it along wherever you want it to go. So for a text field, there's some category methods on certain UIKit classes, and UI text field has one, and it's called, you just do it, access it as a property, rack text signal, and that gives you back a signal that sends a value every time the text field changes. And you might think this is voodoo, but under the hood, you look and you're really just getting a target action on the text field that says send an event for value change or value did begin editing, I believe. And it's piping all these values through this signal that you get. And so it's not some super crazy, there's more to it to make the signal work, but that's basically what's going on under the hood. It's setting up this target action and then feeding the values to the signal.
What other things are generating signals? Are there signals for things like scroll events or pinch zooms or things like that?
You can create signals yourself, and you can create them for pretty much anything. You can observe properties. There's a nice macro called rackObserve, and you just give it a property or you give it a key path, and it'll give you a signal that will send values whenever that property changes. And so it's much nicer API than, say, KVO, which is terrible. So yeah, you can create signals that send whatever you want. You can observe properties that will give you signals whenever those properties change. So yeah, you can manipulate these and create these basically however you want.
That's pretty neat. So this isn't just things that you attach to UI. You could kind of, in theory, attach this to a domain object. So whenever you update that domain object, then it would magically, you could attach a signal to that property and then wire that signal to the UI. And then whenever you change the property in the domain, it would just update in the UI.
Yeah, and you could do that both ways. So your model object updates your UI. Like you have a settings view and you want to update fields based on some user object. And your UI could in turn update your model object. So yeah, you can go both ways and you can make a signal out of basically anything. So it's definitely not just UI stuff. I mean, you can model all your interactions with signals.
Okay, so we've got like a model class. Where would you typically put a signal that you're creating? Would that go on the model? Create a category for it? Like, what's worked well?
It sort of depends on what you're doing. So you might have a person class, and this person has a name, and this is what we're going to wire up to the text field. Depending on what you're doing with it, you might just have the person object in that view controller and just bind the text field to that person in that view controller because you might only be using it there. You could have a signal that goes to the model object. I mean, there's many ways to do it. There's not only one way, so it sort of depends on what you're doing. But I've sort of done smaller things where I try to keep the view controller small, and I might put my model object just as a property in the view controller and do bindings there if I'm binding from UI to the model object.
Okay, very cool. So I want to play the voice of reason here. So we've been creating UIs with kind of the standard imperative method of doing this for a long time. Why do we want ReactiveCocoa? Why would we do this?
I've thought about this a lot, actually, and thought about generally software engineering and tools we use and I guess the future. And yes, we have these tools, iOS, Objective-C. We have these nice SDKs. We know how to program this way in the imperative style. And this ReactiveCocoa is this new thing. It takes some learning. It's got a learning curve. So that's a valid question is, why would we do this? And I think, and you'd probably find other people that had different opinions, but a lot of people think that imperative code is bad. Like writing an imperative style is bad because it's very low level and it's very hard to reason about. And you get up into higher abstractions, higher abstracted languages, and your code becomes easier to reason about. And we're building bigger and bigger apps and with more and more state. And so it just becomes really hard to reason about all this state and the size of these apps we're building. And so using ReactiveCocoa or some higher language, some functional language, these things become easier to reason about for us and easier to make these larger apps. And so it gives you a higher level of abstraction and it gives you easier ways to reason about what you're doing. And so that's sort of one of the selling points is this is just easier to reason about, which allows you to not worry so much about bugs or the various states your app could be in, just write, again, more what you want to do rather than how it should be done.
One of the things that I'm totally stealing this from Josh Abernathy, who's one of the guys that created this. He did this awesome presentation at CocoaConf a couple of years ago, kind of about ReactiveCocoa, but also just more about kind of blowing your mind. And what he talked about was state and how what makes this kind of stuff really valuable is it reduces the amount of state that you have to think about and kind of shared state that you have to maintain. And reducing the amount of shared kind of state in your program is an awesome way to kind of reduce the complexity because you stop having to reason about all of the interactions between different bits of state and you can just start thinking about how things flow from one function to another function. It makes a really big difference in how it means that you can hold small parts of the program in your head and understand them rather than having to hold the whole program in your head all at once so that you can remember all of the different things that are touching this kind of shared state. So I think that's one of the big wins.
Yeah, definitely. And it's impossible to hold the entire program in your head unless it's a very small program. I mean, there's so many states that your app could be in, and what is it doing here, and this property might change here. It really becomes basically impossible to reason about at some point. There's so many different branches. And so, yeah, reducing state is definitely a huge win.
Yeah, I've been doing like client development for a long time, and mainly on kind of desktop applications, way back to MFC and WinForms, things like that. And you end up handling all these different button clicks and text enters, and you left it separate out in different parts of the application. And eventually you kind of got to a point where you'd have like one monster method that kind of handles all the different enabling, disabling, things like that. And this is a way to kind of split that up, which I think works very well for kind of large applications. So you can concentrate on one little aspect of it, of when this button should be enabled or this validation string should be visible, something like that. So I think it's a really powerful paradigm if you can sell it to the rest of your team. Or if you're like me, you work by yourself,
That's a really, really good question. That's a very good practical question. Like if I wanted to start introducing this into my current application that I was building, even if, let's say I'm working on my own, but I have this existing application, do you have any suggestions as to like places to get started? Like a place where you can kind of dip your toe in without having to buy into this in its entirety?
Yeah. One of the things when I first started learning this, I was pretty sold on it. I was like, man, this is awesome. And I wanted to make everything ReactiveCocoa. I was like, I'm going to ReactiveCocoa all the things. And that did not work out very well. And what I realized is that some things you may understand better in the normal style and you just want to write it and get it done. Some things if you work with it, you'll begin to see the patterns in ReactiveCocoa and how to use it. So if you want to try it out, I would just pull in the framework and just start playing around with it. Use just little bits, like where you're like, oh, this seems like a good candidate, and just use it there. You don't have to write your entire app in ReactiveCocoa. It can exist side by side with your other code. So that's something that I would say if you're going to start out is pull it in, just poke around a little bit, use some of the methods, see how they work. Just use it in little places. And as you start to understand it, you can use it more and more. And I think that's an easier way to get into it than trying to just write an entire app in ReactiveCocoa.
What's one thing that you tried that didn't work out the way you thought it would?
Well, the one thing, again, you have this nice macro, this RIC observe, and really it's just a wrapper around KVO. And so maybe you'll think that you want to observe, like, oh, when you use this, you're like, oh my gosh, I can observe property changes this easily. And so you're just starting to try to observe all the things. But as a wrapper around KVO, you might not be able to observe everything. Like I was thinking, oh my gosh, I can observe anything I want. But UIKit is not KVO compliant. So you might try to observe like a UI property and it might work or it might not. It might just break. Or you might try to observe something like, I don't know, something being added to an array or these other things you might think that you can do with this when you first look at it and hear sort of about the magic of it. But yes, not everything works like that. So that there's various things that you might try and that'll just fail. And they most often fail because you don't have a good understanding of the framework. And that's what I found when I was first learning. I was like, why is this not working? This should totally work. And I would think maybe it's a bug, but it's never a bug. It's always me. So
okay, so one thing that you had to make sure that the classes you're observing are KVO compliant. And I still have this discussion with a lot of other developers that don't want to use properties. They just like their IVARs. So it's good to know. So should be KVO compliant.
Yeah, and people are still using just IVARs. That's crazy.
So one thing that it kind of interested me, like I started hearing about ReactiveCocoa maybe in the past 6, 12 months, something like that. But this is more of a pattern that I always associated with Windows and Silverlight WPF stuff that people were doing maybe 3 or 4 years ago. And people were starting to do all these kind of cool things where they could do all these really complex UIs and interactions. But how did this kind of end up in the Mac world? It seems like a kind of a strange chasm to jump. How did that happen?
Well, again, I don't know the entire origin story, but ReactiveCocoa is based on the RX extensions, which comes from the Microsoft world, and these guys at GitHub decided to basically build this up for Cocoa because we didn't have it. There was RX extensions for .NET, there was RX.js, I think there was even RX Ruby. So there's all these things. There was RX Java, but we didn't have it in the Cocoa world, and I'm actually sort of surprised someone didn't get that over sooner when I think about it, because the RX extensions aren't exactly a new thing. So again, I believe it started with the development of the GitHub for Mac app, and that's sort of the origin as I know it.
So is that GitHub app, is that open source? Can we view that?
No, the GitHub app is not. A lot of the components are, which one of them is ReactiveCocoa. So the full source of ReactiveCocoa is out there, and you can look at it and see how it's done. But the actual GitHub app is not.
Okay. Are there any example projects that are using ReactiveCocoa out there? So we can kind of see some examples of how it works.
I actually have a project that I did that is out there. It's on my GitHub page, and I just called it the Rack Example. And I think it's fairly good. There are some other ones. There were some on the ReactiveCocoa wiki page. I don't know that they're there anymore. I'll have to find some other ones, but yeah, there's definitely some out there. And also, Flamingo. I don't know if you're familiar with that somewhat new chat app that's out for Mac, but that also uses ReactiveCocoa.
So that brings me to a question I was going to ask. Presumably, this is going to be a really laboured segue, so I apologise. Presumably, a chat app needs to do a lot of talking to back-end servers and networky stuff. Does ReactiveCocoa play into that as well?
Yeah, and that's one of the really great things about ReactiveCocoa is that you can model pretty much everything with signals. And so when you work with enough APIs, you'll see that, well, this API likes to just post notifications. This API likes to have delegates. This API takes blocks. And so using ReactiveCocoa, you can model everything with signals. And yeah, you can work with whatever your network requests, talking to backends. And so yeah, it plays nice with basically everything. And it allows you to have one unified API to deal with so many various things.
Does it have kind of adapters out of the box so that I can kind of plug in signals to AF networking or like the existing kind of network stuff that's available on iOS?
There are some extensions for AF networking. You can find them on CocoaPods. If you search there, they're not official extensions, but people have made them up. But you don't actually need really an extension. You could write the extension yourself incredibly easily. Because when you create a signal, what you do is you get a block, and this block passes in a subscriber, what they call a subscriber. And the subscriber simply has three methods, which are send next, send error, and send complete. And so, say you have a networking class, and you want to do all your network requests in there, and then you want to be able to get that to a view controller somehow. Instead of doing the normal maybe success failure block, in the networking class, in the success or failure block, you can say send next, whatever the successful data is, or send error if there was an error. And then you can just get a signal that will carry along either this response, whatever you wanted from the network, or that'll send along an error if there was an error. So you can get away from the success failure callback thing that you might have in your view controllers.
So let me see if I can kind of work through a kind of an example that would plug all this together. So let's say I want to allow a user to update his password. If I have a UI with like current password, confirm new password, or whatever, right? Those three fields. So I can plug signals in my viewDid load or something. I can plug in to signals for those text fields changing, and then once they've all been filled out and they're all verified, then I can kind of take those three different pipes and merge them into one pipe, which is like a update password thing, and then take the send button and merge that into the thing. And then once all of those things kind of send a signal together, then I can condense that into one thing that would then go onto the network and make the actual update request. Does that sound like I'm vaguely getting it right?
Yeah, I mean, you can basically do something like that. You have the text fields. You can say enable this button when all the text fields are correct. And when the button's enabled, you can have it fire off this network request. And you could have a method that you would pass it the parameters. It would fire off the network request. And this method could return you a signal that would represent the network request. And then you could transform the network request however you wanted. So yeah, I mean, that's basically
Would I have to still have some kind of procedural code in the middle that kind of bridges the gap between the UI kind of signally stuff of things changing and then me creating this signal in the network or this rack subscribe on the network side of things? Do I still need some imperative code to do that, or can I just set all of that stuff up declaratively at the start of the program and just let it all just kind of flow through whenever those changes happen?
We're working with what is basically a framework built in a language. So yeah, we're still going to have some imperative stuff. You're still going to have to use AF networking, make a request, have a success and failure block, maybe do some stuff to a response object, maybe it's a dictionary and you want to get certain keys out of it. So you're still going to have some imperative code. And
Gotcha.
maybe when you do like a map function, you're going to return something from this map function, but you might be doing sort of an imperative thing within that map function. Like say, take this value, trim the white space from it, its text value, trim the white space, then check its length, and then if that length is something, return a bool, otherwise return another bool. So yeah, there's still imperative code in here, but it's less.
One thing that I'm kind of wondering about here is you mentioned, that you can have a signal that basically triggers a call down to, a back end on the internet service. And then you have another signal that's generated when it replies. Where do you set up that signal for the reply? I mean, do you just put it into the callback, or is there some other approach to that I'm missing here?
So, like, where would you deal with the signal that you get for the reply?
Well, how do you take the reply and turn it into a signal?
For that, say you have AF networking, and you say get with params success and failure, and you have this success and failure block. Mm-hmm. What you would do in your networking class, you would have a method that says make request with the params, but you wouldn't have a success and failure block that you would have for this method. It would return a signal. So you can create a signal with a class method on rack signal called create signal, and you would do your network request within this. It gives you a block. You would do your network request within this block, and in the success block, you have this subscriber, and you would say, subscriber, send next the response object.
Oh, okay.
And then, or in the error block, you'd say, subscriber, send next the error object. And then this method would simply return this signal that would encapsulate this network request, and then you could get access to the next, which would be the response object, or the error, which would be the error, if it errored out.
So these things are these rack subscribers are like almost like promises in JavaScript or another language that has promises, except rather than firing once, rather than promises that resolve or fail once, these things can kind of send a stream of data over and over and over again. So it's still the idea that you create the thing and then attach things into it to say, this is what I want to do when this succeeds, or this is what I want to do when this fails, but it could succeed over and over again. So as it were, like every time someone taps the button or whatever. Does that sound right?
Yeah, that's a good, pretty decent explanation. You can think of signals as a pipe and a one-way pipe. Data flows down the pipe, and a subscriber is the endpoint for that pipe. And you can subscribe to different events the signal sends. So signal, you can get a next, a error, or a completed. And in the case of the text field, it's going to send a next many times, or as many times as the text field changes. So it's going to call this next event many times, but it'll only call completed or error once. So yeah, you could potentially get many next events, or you could get none, but you'll only ever get one completed or one error.
Gotcha. So you mentioned earlier, I think we mentioned a couple of times that there's this origin, or this history, that the origins for this are kind of based on, or inspired by the RX stuff that Microsoft did in .NET. One of the advantages that I think .NET has over Objective-C with this kind of thing is Link and Lambdas and all those kind of things are actually pretty first class in the language now with C#. So you can kind of create an anonymous function. You kind of can do that in Objective-C with blocks, but it's always felt a lot more clunky to me. The fact that blocks are a little bit clunky, does that kind of show up when you're doing this kind of programming? Do you end up having to do some housekeeping to kind of remember what stuff needs to be marked as a block variable and all that kind of annoying stuff, or does that tend to not happen when everything is set up as functions?
I haven't really noticed that or any sort of annoyance with that. A very large amount of these methods that you're going to deal with ReactiveCocoa take blocks, and so it's just what you're doing, and I haven't found too much annoyance with it. Or
I have this suspicion that blocks are annoying to deal with when they're bridging the gap between kind of a functional style and a more kind of OO state-based style, and that's when it gets into lots of pain of like garbage collection or arc and all that kind of stuff. I'm guessing maybe because you're just using blocks all the time and just using kind of essentially functions without state existing outside of the function, then maybe it means that they become a lot more pleasant to deal with. I don't know.
You still do have to worry about retain cycles, and when you pull down ReactiveCocoa, you get this nice macro, or two macros, called weakify and strongify, and they basically do the strong self, weak self dance for you. So you say at weakify self outside your block, and then inside your block you say at strongify self. And that's equivalent to doing weak type of self, strong type of self, weak self. And so you do have some easier methods for dealing with retained cycles, and you do still have to watch out for them.
Okay. That's a shame. It's nice that they make it easier at least. And the other thing, like around kind of the language support, is a lot of the pure functional languages are built around this concept of immutability. So you can't change something. You can't change the properties of a thing. You can just create a new thing if you want to change it. Does that show up in reactive functional stuff for Cocoa? Do you see, is it bad form, or does it lead to confusion if you start mutating objects as they're flowing through these pipelines, or does that not show up?
Well, the signal itself is immutable. Once you create a signal, you can't change it. Any operator, map, filter, reduce, whatever operator you do does not actually affect the signal. So signals are immutable. Any operator on a signal returns a new signal. You are transforming data, like when you do a map function, you're obviously mutating the data somewhat. So yeah, you're mutating data inside these functions, but the signal itself can't ever be changed. It is immutable. And yeah, you want to avoid mutability as much as you can. But again, without any mutability, we have a very, very boring app. So we just want to limit places where we mutate things.
Okay, one thing that kind of confused me when I started kind of changing my development approach from like imperative to more declarative is that the techniques I was used to doing for debugging didn't really work. Like I was used to listening for an event handler and kind of stepping through stuff and stepping into things. Can you give us any advice for kind of debugging kind of reactive stuff?
It's definitely harder. When you have simple stuff, it's simpler. You can maybe say your data is coming out wrong. You could set a breakpoint in like a map method. Make sure you're transforming things right. When it gets larger and more complex, it gets a bit harder. A lot of the signals, when they're created internally, they get a name set to them. So if you get like a crash or a runtime error, you'll have this signal and it'll have a name attached to it. So that makes it a little easier. But yeah, some things you won't be able to catch at compile time. So I don't have any specific debugging strategy, really. But again, sometimes it might be something that you're doing maybe in a function that you can just break on, or there might be something at runtime, like you're trying to assign a signal to like a text property because you're sending a signal and not text, and that'll break at runtime, and it usually gives you a pretty good exception for that.
Does ReactiveCocoa offer a T method where you can kind of insert like a T into a pipeline, as it were?
Not that I know of. There might be in there. It's a fairly expansive framework, so it could be in there, and I might not have just happened across it.
Gotcha. Because I've always found that useful if you've got like a long chain of kind of if you've basically got a bunch of stuff stuck together, a pipeline of operations, you can kind of insert, and things aren't working the way you want, you can kind of insert a T into the middle of that pipeline and use it to kind of sample what's happening without disrupting the flow. So I kind of think of it as like attaching like a probe or a tap or like a wiretap into the sequence of events or signals that are flowing through the system so that you can see what's happening without actually changing the system. But I would guess maybe there's something in there. And if there isn't, you can just do a map that doesn't actually transform anything. It just has the side effect of letting you see what's happening inside of the pipeline.
Yeah, I'd imagine, again, it might be in there. I might not have just seen it yet, but or you could do, like you were saying, just have a map and look at it there.
So the last question I've got is around testability. Does this lend itself to more testable code, like more test automation, or is it tricky to write tests for this kind of stuff?
I would say it can be more tricky because just of the nature of it. Like, what are you testing exactly? You've got these signals, and you're not testing the signal. You really want to test what it's sending. So, and a lot of this stuff can be done in blocks, and it could be done asynchronously. And testing asynchronous code and testing blocks is a little harder. So, it is possibly a little harder to test. That said, I haven't done too much testing with it. I've only done a little. So, that's what I have on that.
All right. Any other things that we should talk about related to ReactiveCocoa? I know that next week we're going to be talking about the functional reactive programming book.
Is that the one Ashfurrow did?
Yes.
That one's pretty good. I've got that and I enjoyed it. If you want to see a language built for functional reactive programming and not simply an extension, there's a language called Elm, and it's for web programming. And it compiles down to HTML, CSS, and JavaScript. And it's built from the ground up for functional reactive programming. So if you want to see what that actually looks like natively, then you should check out Elm.
All right, cool. We'll put a link to that in the show notes. And let's go ahead and do the picks then. Jane, do you have some picks?
Yeah, I've got one pick. So my wife has type 1 diabetes, and so she'll take like an insulin shot. She's got a pen, and every so often she'll forget if she took a shot or not, which, if you're trying to manage your insulin, that's kind of a big deal. Like, I'm the type of person who forgets if he, like, shampooed his hair, and the results of that, not too bad, but this is something that actually can affect people with diabetes. You take too much insulin, your blood sugar goes very low, that's very bad. So this company called Timeslin made a thing you put on your insulin pen, and they're selling it in many other countries that are not the U.S., but they've got an Indiegogo campaign to try and get through the FDA, which is trying to keep us safe by, not letting us buy this thing. But they've got an Indiegogo campaign to help raise money for kind of the FDA process. So it seems like a pretty cool thing. You can get it for like $30, kind of a pre-order thing. But that's my pick. So Timeslin. If you have people that kind of have diabetes and take shots, this is actually a very cool product for them. So that's my pick.
Cool. Pete, what are your picks?
I'm being a little bit boring this week, and I'm going to pick things mostly to do with the topic at hand. So my first pick is a write-up on ReactiveCocoa from the inimitable Matt Thompson. So NS Hipster has an entry on ReactiveCocoa, which is a good read. It talks about the basics, and I didn't read the whole thing, but I just assume it's going to be good because he always writes good stuff. My second pick is the slides from this talk that Josh Abernathy did called Better Code for a Better World. I'm not sure how well the slides are going to get the point across. I'm not sure if there's a video recording of this talk anywhere, but it was a really good talk, and it talks about some of the details of how ReactiveCocoa works, but mainly the first half of the talk, which I really loved, was just talking about why these principles can lead to a saner developer life, which I'm a big fan of sanity in general. And then my last pick is a tool that Facebook just released called Chisel. So Chisel is pretty cool. It's a bunch of LLDB macros that you can kind of insert into your debugger, into the LLDB debugger that kind of Xcode uses by default these days to help kind of debug what's going on with your application. So you can, once you're in the breakpoint and you've got the debugger in the command line, you can kind of use all these little commands to like print the view hierarchy into the debugger, or show or hide views to see what's underneath them, or like highlight things so you can see which view is where. So loads of really kind of useful things for you to kind of mess around with the visual hierarchy of your application kind of live while it's in the debugger to kind of try and figure out what the heck is going on. So it's a really cool tool. It's kind of one of those things that seems obvious in retrospect, but I guess no one had built one of these things before. So yeah, check it out. Chisel. And that's it for me.
Awesome. At Mountain West, I think it was Mountain West JavaScript, might have been Mountain West Ruby Conference, somebody gave a talk about iBeacons and the way that they set stuff up and made it work and hooked it up to their app. So my picks are going to be related to that. Before I do that, though, I just want to mention that we did a functional reactive programming episode on JavaScript Jabber, and so I'll put a link to that in the show notes as well. Anyway, so he was talking about using the Estimote iBeacons, and the problem was that I didn't really want to get in and hack it, and I tend to like to do things on the cheap, and so I wanted some more flexibility, and I wanted a little bit less expensive thing, and I've had this Raspberry Pi sitting on my desk for a while. And it turns out that you can actually get some hardware and build your own iBeacon out of a Raspberry Pi. And so since I had that sitting on my desk, I just bought the other couple of things that I needed to make it work. So I've got a link in there to Bluetooth, USB. It's not really a dongle in the sense that it hangs off of your machine, but it is a little like nub that you plug into your USB. And so you can hook that in there, and then you can... you probably want to get the Raspberry Pi with the power supply and the operating system. It's the Raspbian operating system, so it's kind of a stripped-down Linux for the Raspberry Pi. And that's all pretty inexpensive. And the Raspberry Pi does a whole lot more stuff, so it's kind of a fun little kit to have anyway. But then there is a post on how to build iBeacon with Raspberry Pi, and I'll put a link to that in the show notes as well. But yeah, that's kind of what I've been looking at lately. And so, I'll go ahead and just pick that stuff. Terry, what are your picks?
I'm going to go with two. The first would be Sim Folders. If you haven't heard of it, it's a nice little utility that sits in your menu bar that lets you quickly access the folder of apps in the simulator. So, say you're working with core data, and you want to get to the actual SQLite file and maybe view it in some sort of viewer. Sim folder makes it easy. Just select the app, and it'll open up the directory, and you can pop in the documents right there, and there's your SQLite thing. You can view it. So, Sim folders is a great little utility. And my second one would be AppCode. If you haven't used AppCode, that's sad, because AppCode is incredible. And as much as I love Xcode, AppCode is just miles ahead in pretty much everything. Writing code, refactoring, just everything. So, do you use AppCode?
I do. I always get annoyed because I end up going back to Xcode accidentally when I'm editing, nibs.
Yeah.
But I'm a big fanboy of what's it called in general. Those guys.
IntelliJ.
Yeah.
JetBrains.
JetBrains,
yeah.
thank you. Yeah, JetBrains are awesome.
Yeah,
they do good stuff.
So yeah, AppCode. If you haven't used it, try it, and you'll hate Xcode, unfortunately. Except Xcode looks better. It does look a lot better than AppCode. But other than that, the writing code and refactoring is just miles ahead in AppCode.
When do we get the native version of AppCode?
Probably never.
Yeah, probably never.
I want it. I don't like Java. Yeah, it does feel like a Java app, even though it is awesome. You definitely know you're using Java.
I see. I was going to make a couple of coffee jokes, but I passed. All right. Well, thanks for coming, Terry. Really appreciate you taking the time and sharing your expertise. And if people want to get a hold of you or find out more about ReactiveCocoa, what's the best way to do that?
You can get me on Twitter. My Twitter handle is TLewisII, Terry Lewis II. And if you want to learn more about ReactiveCocoa, you can go to the GitHub repository, the official one, and they have a ton of great documentation there. I also have two projects, actually. I have an example project on GitHub that's open source. It just shows various examples of using ReactiveCocoa. And so it's just table view, and it shows different things that you would normally do in an app, and just shows how they're done with ReactiveCocoa. I also have another one called Rack Training, and it's sort of a step-by-step walkthrough of getting started with ReactiveCocoa. And so it just builds up with tags. You start at tag 01 and then go to tag 09, and you see sort of stepwise how all this works and how to work with it.
All right, cool. Well, then we'll wrap up the show. Just a note to those of you who haven't started it yet, we are reading Ash Farrow's book, Functional Reactive Programming. And thank you all for listening. We'll catch you all next week. Hosting and bandwidth provided by the Blue Box Group. Check them out at bluebox.net. Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.